Hello, this is Sri Banerjee, and in this session I will be lecturing on quantifying and comparing epidemiological measures in the context of other measures than incidence and prevalence that are important in considering epidemiological statistics. So without much further ado, let's jump right in. So some examples of crude rates are as follows. There's crude birth rate and fertility rate, general fertility rate, infant mortality rate, fetal death rate, neonatal mortality rate, maternal mortality rate. I won't be going over every single rate, birth rate, mortality rate, and going over calculations of all of them, because really all of them you can read in a book and follow the formula. But I did want to go over the significance of certain rates, especially when you're comparing nations in terms of global health, or when you're comparing county data to maybe the state data or nationwide data. A lot of times certain measures are more applicable than others, and so I'm going to go over some of them, and then plus some of these measures are in your homework in your assignment, so it might be worth your while to be listening to these. So first and foremost, infant mortality rate. This is one of the key indicators in international comparisons. When you have a high rate of this, there could be any number of reasons that this could be high. And when you have a high rate, you know that there is some sort of health need that's being unmet. Maybe there's not enough perinatal care. Maybe mothers aren't getting their care, and maybe they're not getting skilled birth attendants. There's many reasons for infant mortality rate. So what is it? Infant mortality rate is actually the number of deaths among infants under 1 year of age. So I provided you with a sample calculation as well. If you have in your infant mortality rate, if you have the number of infant deaths among infants aged 0 to 1 year basically during the year, and then you have the number of total live births during the year, then if you're able to divide that and then multiply it by 1,000, then you can determine what the infant mortality rate is per 1,000 live births. Now I want to reiterate why it is necessary to be depicting some of these rates per 1,000 live births, or per 100, or as you saw in another example that I provided. The reason is that if you didn't do it per 1,000 live births, the number would be a decimal, and it's harder for us to grasp a number below that's not 1. So for the sake of simplicity and the sake of understanding this better, we present this in terms of per 1,000 live births. And if you go into the World Health Organization website, if you go into different websites, you can see all the different indicators. In fact, the CIA fact book also has a list of infant mortality rates. Maternal mortality rate is very similar, except this is expressed in terms of 100,000 live births. So when you do the ratio of number of deaths assigned to causes related to childbirth over number of live births, then you multiply that by 100,000, and this is all during 1 year usually. And these are also indicators of socioeconomic factors. It could indicate also certain conditions like eclampsia, hemorrhage. Again, skilled birth attendants not being present, and it's surprising to see in how many parts of the world there is not a skilled birth attendant because of the lack of resources, lack of primary healthcare, basic healthcare needs. Another very important calculation that you'll actually be doing in your assignment is cause-specific rate. Now, this is a mortality or frequency of a given disease over population size at midpoint of time period. So it's again part of a whole. If you and this is again done per 100,000. So if you're looking at HIV in 2003 in a particular age group, then there are 1,588 individuals infected with HIV, and the total population at that time in that age group was 39 million, so that's 4 per 100,000. So proportional mortality ratio is actually a percentage, and this will be another thing that you'll be doing in your assignment. So if we look at the same example as before, this is another way of expressing the relative importance of a specific cause of death. So HIV among 25 to 34-year-olds, what is the percentage importance of this? So that this will give you a good depiction of that. So mortality due to a specific cause versus mortality due to all causes. So the 1588 is the mortality that was from HIV versus all mortality of all of the diseases, and that's 3.8%. So adjusted rates, this is a concept that many times can be confusing, but if you do it systematically, and this is another thing that you will want to do you'll have to do in your assignment, is the adjusted rate. If you do this systematically, then you'll be able to approach at your answer very easily. So it's a summary measures of the rate of morbidity and mortality in a population in which statistical procedures have been applied to remove the effect of differences. That's key. It's removing all the differences that are there between the comparison. So you're comparing different populations, but you do a calculation to remove that effect. So there's a direct method and an indirect method to do this. The direct method I have not covered in this lecture. Is actually covered in great detail in the book, but the indirect method is something that I have covered because it's something that is quite important and actually comes up in your assignment as well. So it may be used if age-specific death rates of the population for standardization are actually unknown, or it could be unstable. So, for example, because the rates to be standardized are based on a rather small population, the death rate of that subset of the population may not be known. So the standardized mortality ratio allows us to evaluate the results when this information is not known. The specific death rate, the age-specific death rate is not known. So I bolded this here because this is something that is very important. From a very simple, simplistic manner, standardized mortality ratio is the observed deaths over the expected deaths times 100. that's the simple formula, but many might ask the question, how do you know how do you come up with these two numbers, the observed deaths versus the expected deaths, from different data sources? And so I'm going to go over in more detail the calculations. So the number, in this case, you were given the number observed versus expected, and so it makes the calculation easier. So just as a general rule of thumb, how do you interpret the standardized mortality ratio? If the observed and expected numbers are the same, then you know that the indicated mortality rate is actually the same. The observed mortality is not something unusual, and it's not different than the expected. But if the SMR is actually 2, that means that the study population actually has a 2 times greater than expected mortality rate, which is cause for alarm. So there's something happening. So in this situation right here, what you're doing is you're actually calculating the expected number of deaths in the population of interest. Now, in the example in your assignment, you'll have lung disease as the population of a number of deaths in lung disease, and it'll actually have an example of individuals that are roadside construction workers. So I'm going to use this as an example to show how to do the calculation. So if you take, for instance, now look closely here and take a look. This death rate is actually per 100,000. So as I said, when you're calculating death rates, you have to multiply it by 100,000 in order to get the death rate per 100,000. Now you're working backwards in order to get the expected number of deaths in population of interest. So what you're doing is multiplying 7,989 times 81.5 and then dividing that by 100,000. So you go down the line, you multiply columns columns 2 and 3, and then divide that by 100,000. So that's how you get 6.5. 7,989 times 81.5 divided by 100,000 to get 6.5. You go down the rows and then you add these numbers up and you get the expected number of deaths, which is 987.9. The observed number of deaths is 502. Now in the assignment, you'll have to actually add up the observed number of deaths in another column. So once you have those two numbers, you can find out what the standardized mortality ratio is, and here it is 50.8%. So then what you do in order to get the indirect adjusted mortality rate, you actually multiply that standardized mortality ratio times the crude death rate to get the indirect adjusted mortality ratio. The mortality rate. So that sums up the way to calculate through an indirect age adjustment. So you'll actually have these numbers, the crude death rate, given to you in the assignment, and you'll be able to figure out what the indirect adjusted mortality rate is. And you shouldn't have any issues in calculating this, even though it may seem complicated at first glance. Thank you for listening.